If you landed on Venus, you wouldn't die from the heat first. You'd be crushed, flattened, turned into a pancake before your brain even had time to register what was happening. And that's just the beginning of why nobody who goes there is ever coming back. Venus is called Earth's twin. Same size, same mass, same general position in the solar system. From space, it even looks kind of pretty with all those thick white clouds covering the surface. But that nickname? Completely wrong. Venus isn't Earth's twin. It's Earth's evil twin. The kind that looks similar on the outside, but is absolutely nightmarish once you get close. And here's the thing. We've actually sent probes to Venus. Multiple countries have done it, and every single one of them died. Not failed, died, crushed, melted, corroded into nothing within hours or even minutes of landing. Today, we're going to walk through exactly what would happen if a human ever tried to land on Venus. And I'm warning you now, this is going to get uncomfortable. Because Venus doesn't just kill you, it kills you in layers, one horrible thing after another, stacking up so fast that there's no possible way to survive, not with current technology, not with future technology, maybe not ever. Here's what most people know about Venus. It's really hot. And yeah, that's true. The surface temperature on Venus is about 465 degrees Celsius. That's 870 degrees Fahrenheit. Hot enough to melt lead. Hot enough to make your spacecraft glow red just from sitting there. But temperature isn't the main problem. The main problem is pressure. The atmospheric pressure on Venus is 92 times higher than Earth's. 92 times. To put that in perspective, that's the same pressure you'd experience if you were 900 meters underwater on Earth, almost a full kilometer down in the ocean. Now think about what happens to things at that depth. Submarines have to be built like tanks, thick metal hulls, tiny windows, everything reinforced. And even then, if something goes wrong, the hull cracks and the whole thing implodes in less than a second. That's what you're dealing with on the surface of Venus, except it's not water crushing you, it's an atmosphere made almost entirely of carbon dioxide, thick, heavy, toxic gas pressing down on you from every direction with enough force to crumple steel. So the challenge isn't just don't die from heat. The challenge is don't get instantly crushed by an atmosphere that weighs as much as an ocean. And we haven't even talked about what that atmosphere is made of yet. Let's say you're in a spacecraft. You've traveled millions of kilometers through space. You've survived the journey, and now you're approaching Venus. From orbit, you can't see the surface. All you see is clouds. Thick, yellowish-white clouds that cover the entire planet. And those clouds aren't water vapor, like on Earth. They're sulfuric acid. That's right, Venus has clouds made of acid. Concentrated sulfuric acid. The same stuff that's in car batteries. The same stuff that can eat through metal and burn skin on contact. As you start your descent, you're dropping through layers of these acid clouds. Your spacecraft's outer shell is already being corroded, eaten away, and you're not even close to the surface yet. But here's where it gets weird. For a brief moment, about 50 to 60 kilometers above the surface, the conditions are almost Earth-like. The temperature is around 20 to 30 degrees Celsius. The pressure is roughly similar to Earth's surface. Some scientists have actually suggested that this layer of the atmosphere, this narrow band floating high above the hellscape below, might be the best place for humans to explore Venus. Not on the surface, in the clouds. But you're not stopping there. You're descending. And as you drop lower, things start changing fast. The temperature climbs. 100 degrees, 200 degrees, 300 degrees. Your cooling systems are working overtime just to keep the inside survivable. The pressure is building. You can feel it in the way the hull creaks, small pops and groans as the metal starts to compress. And it's getting darker. Even though it's daytime on Venus, the atmosphere is so dense that blocks so much sunlight that by the time you're near the surface, it's like being in a dim orange-tinted twilight. You can see maybe a few hundred meters in front of you. Everything beyond that fades into a murky haze. Finally, you land. The engines shut off. You've made it to the surface of Venus. You have maybe 2 hours before everything fails, maybe less. The ground beneath you isn't like Mars. It's not a red desert with rocks and dust. Venus has volcanic plains, lava flows that hardened millions of years ago, mountains, craters. It's geologically active in some regions. There are volcanoes that might still be erupting even now. But you can't see much of it because the atmosphere is so dense that visibility is terrible. It's like being underwater, but instead of water, it's just thick, crushing air pressing in from all sides. Your spacecraft's hull is creaking constantly now, not because it's poorly made, but because the pressure outside is so extreme that every tiny imperfection in the structure is being tested. Rivets, seams, welds, everything is under stress. The temperature inside your spacecraft is climbing. Your cooling system is fighting a losing battle. Outside, it's 465 degrees. Inside, it's supposed to be 20 degrees. But the heat is seeping in, slowly, steadily. There's only so much insulation can do when the temperature difference is that massive. And then there's the wind. On the surface of Venus, the wind is slow, only a few kilometers per hour. But because the atmosphere is so dense, even slow wind has force. It's like being in a gentle current underwater. It doesn't feel fast, but it pushes you. It moves you. It's relentless. You're sitting in a pressure cooker, literally. The atmosphere is carbon dioxide, which traps heat incredibly efficiently. That's why Venus is hotter than Mercury, even though Mercury is closer to the Sun. It's a runaway greenhouse effect. The heat can't escape. It just builds and stays there, baking everything. Let's talk about what's happening to your spacecraft in real time. The Soviet Union landed several probes on Venus back in the 1970s and 1980s as part of the Venera program. These weren't cheap missions. They were heavily armored, built specifically to survive Venus's extreme conditions. Thick pressure vessels, advanced cooling systems, the best technology the Soviets had at the time. Venera 13 holds the record for longest survival on Venus's surface. It lasted 127 minutes, just over 2 hours. It sent back some photographs, the only images we have from the surface of Venus. Blurry, orange-tinted shots of flat volcanic rock. And then it died. Venera 14 lasted 57 minutes. Venera 19 lasted 53 minutes. Every single probe that has ever landed on Venus has failed within 2 hours. Why? Because everything fails at once. The heat melts seals and gaskets. The pressure compresses the hull until weak points crack. The sulfuric acid vapor corrodes any exposed metal. Electronics overheat and shut down. Batteries drain faster in high temperatures. Cooling systems can't keep up. Structural supports buckle. It's not one thing that kills the spacecraft. It's everything, all at the same time. A cascading failure where each problem makes the next one worse until the whole system collapses. Now, imagine you're inside that spacecraft. You're watching the readouts, temperature rising, pressure readings climbing, warning lights flashing, hull integrity dropping, and you know, absolutely know, that there's no way to stop it. You can't take off. Launching from Venus's surface would require a rocket powerful enough to lift off against 92 atmospheres of pressure. We've never built anything like that. It would be a massive, complex system that would need to survive the exact same conditions that are killing everything else. You can't wait for rescue. There's no rescue coming. Nobody can land next to you and pick you up because they'd have the same problem. And even if they could, how would you transfer from one spacecraft to another in an environment that would kill you instantly if you stepped outside? You're stuck. Let's say you tried. Let's say you put on a spacesuit, the best spacesuit humanity has ever made, and you opened the hatch. First, the pressure would hit you. 92 atmospheres. That's like having a car sitting on every square inch of your body. The spacesuit would need to be built like a deep-sea diving suit, not a spacesuit. Thick, heavy, rigid. And even then, weak points would fail, joints would crack, seals would rupture. But let's say the suit holds. You step out. What happens next? The heat seeps in. Your cooling system, assuming it's somehow working, would be overwhelmed in minutes. Your body starts to overheat. Sweating doesn't help because the sweat can't evaporate in this pressure. You'd cook inside your own suit. Your visor would start to fog, not from your breath, from the heat. The materials would begin to soften, plastics would warp, metals would expand. Nothing is designed to operate at 465 degrees for more than a few minutes. And you'd be breathing, or trying to breathe, air that's been cycled through a filtration system that's already failing. Carbon dioxide is toxic in high concentrations. Even if your suit has oxygen, you're one malfunction away from suffocation. You'd last maybe 10 minutes, maybe 15 if you're incredibly lucky and everything works perfectly. But here's the thing. Even if you survived all of that, even if you somehow made it back inside the spacecraft, you're still stuck on the surface of Venus with no way to leave. This is the part that doesn't get talked about enough. Imagine knowing that you're going to die and there's absolutely nothing you can do about it. Not in a sudden way, not like an explosion or a crash where it's over in seconds, but slowly, over hours, watching systems fail one by one, watching the temperature climb, watching the hull buckle. Astronauts are trained for emergencies. They're trained to stay calm under pressure. They run simulations of disasters so they know how to respond. But there's no simulation for this. No training for you're on a planet where rescue is impossible and death is guaranteed. You'd have communication with Earth for a while, as long as your transmitter works. You could talk to mission control. You could say goodbye to your family. But eventually, even that would fail. The heat would fry the electronics, the antenna would warp, the signal would cut out. And then it's just you, alone, in a metal box, on the most hostile planet in the solar system, waiting for the end. The psychological weight of that is almost worse than the physical danger. Here's the strange part. Despite all of this, scientists still want to go to Venus. Not to the surface, that's a death trap, but to the upper atmosphere, that narrow band where the temperature and pressure are almost Earth-like. There have been serious proposals for floating habitats, giant balloons filled with breathable air, which on Venus would actually be a lifting gas because the atmosphere is so much heavier than oxygen and nitrogen. You could have entire cities floating 50 kilometers above the surface, protected from the heat, protected from the pressure, close enough to study the planet, but far enough to survive. It sounds like science fiction, but the physics actually works. It's more feasible than colonizing Mars in some ways, because you wouldn't need to build underground, you just need to stay in the air. But the surface will never be accessible to humans, not in our lifetimes, probably not ever. Because some places aren't meant to be explored in person. Some places can only be studied from a distance. And Venus's surface is one of them. Every mission to Venus has been a sacrifice. The spacecraft are designed knowing they won't come back, knowing they'll be destroyed. But they send back data. Venera 13 and 14 sent back color photographs. They measured soil composition. They recorded wind speeds and temperature gradients. Venera 9 and 10 sent back the first images ever taken from the surface of another planet. Those images are haunting. Flat rocks, dim orange light, a completely alien landscape. And you can almost feel the weight of the atmosphere just by looking at them. More recently, the Parker Solar Probe has flown by Venus multiple times, studying the atmosphere from orbit. The European Space Agency's Venus Express spent 8 years orbiting the planet, mapping its surface with radar. And Japan's Akatsuki orbiter is still there, watching the clouds and weather patterns. But nobody has landed on Venus since 1985. Not because we don't want to, but because it's so expensive and so difficult, and the survival time is so short that it's hard to justify. Still, scientists keep talking about going back. New materials, new designs. Maybe a probe that could last a full day instead of just 2 hours. Maybe a sample return mission that could grab some rocks and launch them back into orbit before the spacecraft dies. But humans? No, we're never landing humans on Venus. It's just not survivable.